Methane is one of the most potent greenhouse gases we emit, but spotting where it's leaking isn't easy. Kuva Systems is changing that. Based in both Canada and the US, they've developed a shortwave infrared camera that can detect and quantify methane emissions in real time. With help from Emissions Reduction Alberta, they've taken this technology from a mobile prototype to a rugged, cloud-connected monitoring system that operates year-round, even in the remote winters of northern Alberta. With 2 rounds of funding from ERA, Kuva was able to test, iterate, and ultimately reimagine their product, moving from a cart-based detection tool to a full-scale tower system capable of continuous emissions monitoring. The result is a new standard for how operators detect, understand, and respond to methane leaks in Alberta and far beyond. We wanted to learn more, so we sat down with Thomas McArthur, Chief Operating Officer at Kuva Systems, to talk about how the technology works, what they've learned from working in Alberta's oil and gas fields, and why context, not just detection, is the key to cutting methane emissions. Here on Carbon Copy. Before we dive into this episode, a quick note. Since our conversation with Thomas McArthur was recorded, Kuva Systems has joined forces with Sensirion, a Swiss-based sensor manufacturer with a global footprint. And while the Kuva team remains fully in place and committed to serving the oil and gas sector, this new chapter expands their capacity to offer integrated, scalable solutions for continuous methane monitoring around the world. You can find more about the acquisition at kuvasystems.com. Now, on to the episode. Thanks again for joining us. It's great to have you, and really looking forward to hearing a little bit more about what it is that you do and a little bit more about Kuva. Now, I know you have a very interesting story about Kuva, and in particular, ERA's role in that. Can you tell our listeners a little bit more about that?
Yeah, sure. So I joined Kuva Systems back in 2018 as a field applications engineer. I was the first Kuva Canada employee, and before ERA, there was no Kuva Canada. The first ERA project we had really instigated setting up a subsidiary, and I became the first employee. And then kind of growing from that, I became the VP of Customer Operations, and now I run most of the engineering side and the production and services side of Kuva Systems.
It's fantastic. It's pretty rapid growth for the organization, rapid growth for yourself too in your career, which is great. Some of our listeners might be familiar with Kuva, but many of them may not. So can you introduce our listeners to Kuva Systems and describe what it is, the technology that you've developed? What does it actually do?
Yeah, so at the core of Kuva Systems, we have a shortwave infrared camera that can detect and quantify methane emissions. And we package that up with a software solution that enables our users to really see, size, and solve their methane emissions.
Fascinating work, and I think really important work around the methane space. My understanding is that there's been a lot of evolution as time has gone by when you first started working on this. So can you tell our listeners a little bit, what was the company originally trying to build when you started out, and how did that first concept take shape?
Yeah, it's a great question. So at the beginning, we were really trying to build a portable camera that could be a substitute for an existing technology where that is a handheld video camera that costs $150,000, where people take it from site to site and they look closely at all emissions, all potential emission sources, and they can see those and tag them to be repaired. And, our technology is inherently low cost, and we thought we could build a substitute for that where we can take it to different sites again and do the same thing, just at a much lower price point. And that's where we began the journey, because we knew there was a market for it, and we knew that if we developed something that could compete with it, at 1/10 the cost or something similar, we'd certainly have a much better entry point into the market.
And so that first ERA-funded project was really an early proof of concept. And is that what you were trying to achieve with that? Was that the aim of that first project, was trying to develop a substitute? Or what was that first aim? What were you trying to test? And what did you ultimately learn from that first work?
Yeah, really it was to prove out the detection capability of the system, that we could build something that operates on this shortwave infrared principle, and we could be able to see gas with this camera. And we wanted to turn it into a product that would be easy to use and people would enjoy to use. And that was the primary goal of the first ERA project. I think as we went through the project, and if I can set the stage, when we initially deployed this mobile solution, this golf cart, we pushed it around throughout gravel and mud and ice and snow. And I'll tell you, I broke more than one wheel pushing this tripod through these conditions. It was, as I say, you wouldn't play golf in this, so why would a golf cart work in these areas? And so the learning that we had from trying to deploy such a kind of a product that was initially designed for fairways to our rough terrain, we definitely had to come back to the drawing board and re-envision how this might work with good reliability and customer kind of satisfaction. Because you can imagine that if you were playing golf and your golf cart broke every time you went to play, you would not use that anymore. But it was really more than just changing how we pushed it around. We changed it so that we designed our own tower at the end of this second phase of the second ERA project. We made it so it's all patented, and it's this really elegant design where we've designed this base that folds up, and you place 3 concrete blocks around, and you can place the base on top of these concrete blocks, unfold it, and then you can erect a tower, which so there's no ground penetration to any of the blocks on the ground, and the tower just raises up from horizontal using a winch and a gin pole system. And we've had towers in the field for years now of our own design. So I think that's a big kudos to our engineering team for designing such a customer-friendly system that is so rugged that it can withstand, the winds of Williston and the ice and snow that we get up here, and all of the elements that have been thrown at it. And then you can, at the end of the day, if you want to move the camera, you can lower it down, pack it all up, and in less than 2 hours you can ship it out to the next site. So I think those types of innovations all stemmed from these initial deployments that we had with ERA.
Sounds like almost like as you reflect on it, you're surprised that you had some of those challenges when maybe they would have seemed obvious, but you just never know until you've tried.
Absolutely. Yeah, it's something that you got to fail fast, and you see the problem and you come up with another solution, one that hopefully works better. So it was pretty cumbersome to get to that, but it did teach us that the product was able to see gas, and it really excelled when it was able to sit in one spot for a extended period of time to be able to rescan a scene continuously.
So it sounds like your tech works, and then you realize, but really capitalizing on the potential of this, the current way you're doing it is just not optimal. So clearly that must have got the gears turning for you and starting to think a little bit about, well, what's next? So what did that second project with ERA, that second grant, allow Kuva to do that maybe wasn't possible up until that point?
Well, I think, the learning from the first one was that, as you say, it was cumbersome and it wasn't ideal as a substitute that we had initially set out to do. But there was a second portion of that initial project that we had, where we had this a light tower trailer, one of these things that you set up at construction sites with lights on it, diesel generator, and it would have a 10-meter tall mast. And we put one of these cameras on top of that, along with a enormous light, literally 1 meter by 1 meter by half a meter, up 9 meters in the air, and looking at the tops of tall tanks, because we knew that tanks were a pretty persistent emitting source of methane, and in order for us to be able to detect that, we got to be above those sources. So when we learned that we could do this and leave it up there and actually continuously monitor these types of things and see the fluctuations in emissions that do come from sources like tanks, that was kind of a revolutionary thought, that we were able to, determine that if we can do this well and easily and set this up, you can keep outside of the hazardous zone of the tank, so you're not in the emissions. You don't need to be there to touch it, and it really allows you to understand the emissions profile from this tank and this set of tanks. And by doing that, we learned that this could really be a market for us. It was around the same time that a lot of reports were coming out about the prevalence of tanks being a source of emissions. And so knowing those two things, that the mobile pushcart solution didn't work well, and that we worked well at heights in a fixed location, and then combining that with kind of a new market driver for continuous emissions monitoring, where people are understanding that emissions aren't continuous, they're intermittent, and they can happen at any time. And just by showing up with this handheld device, a lot of these go missed. And so the market need for continuous monitoring was budding at this stage around 2020. And we realized that if we redesigned the camera in such a way that we could see a lot further, we'd be able to set this up at site and use it for continuous monitoring. We'd be able to cover a vast area, and we'd be able to do it continuously. So we really had to, rethink how the product worked, how it was built, the physical components of it. And it would be connected by the cloud as opposed to just local on the tablet. And it was a complete shift in the product itself in order to, suit the market and suit the product. And, ever since then, we've been developing that. But the second ERA project was really all about building, commercializing that, testing it in the cold winters of Alberta, in the hot summers, and making sure it was robust, and able to withstand the rigors and the elements that are thrown at it when it is left out there in the middle of winter for without anybody going to visit for months and years even.
Such an interesting story of how this has evolved over time, Thomas. I want to come back to the tech, but just for a moment, just in that time, a lot of change, a lot of development, and it takes a team to do that. And one of the things I was curious about is, how has the team within the organization evolved since those early days in terms of, how many people are involved, in terms of where are you based location-wise, where are these people? It sounds like once it got going, the momentum started to develop, and as you want to grow things, you need people for that.
Yeah, absolutely. And so Kuva was originally founded in Cambridge, Massachusetts, by a couple of folks who had consulted to the U.S. Defense Department, and they really had the vision to build this, and that's where the mechanicals and the physical team, the team that builds the cameras, lives and continues to live. And there's, that team's kind of grown from 10 to 20 people within Cambridge. But here in Canada, having been the first Canadian employee and seeing the software team and the field team and all of the expertise we have here in Canada for that, we've grown the team in Canada to be about 30 people now. So it's outgrown the U.S. side, and a lot of that was, thanks to the ERA grant, especially the second one that's helped us commercialize this second continuous emissions product.
Well, we're certainly happy to have been, played a small role at least in helping you grow and helping really build out this technology, and really great to see how the team in Canada and Kuva within Canada has grown so much. Taking us back to the tech, you were talking about this, how you've shifted from that early concept of mobile cart, you're now into a more stationary approach, the camera, the tower, shifting into the cloud system, obviously generating a lot of data when you're doing continuous emissions monitoring. And then you were talking about some of those harsh environments. Alberta's a cold climate. What were some of the lessons that you learned from deploying the system in some of these more challenging and harsh environments?
Well, not just harsh and challenging environments, but remote. I think that's another key aspect of it. Like, I think some of the things that we developed over that second ERA project was, the ability to really communicate on all levels with the camera. So if you have a communication problem, you would need to have somebody might need to go out and unplug it, power cycle it, and plug it back in. So developing things that you can manually or automatically reestablish a connection to it, that was really important. I think building that robust technology, the systems to be able to monitor and maintain the equipment is super important. And it's really costly to have to visit somewhere in northern Alberta many times, let alone in the winter. So it's definitely one of the key aspects about that is all around the communication and the robustness of letting it be there without any intervention. So, being able to recover itself is definitely a big part. And then monitoring those signals to make sure that when you do start to see degradations in something like battery life or health, you're able to preemptively visit and address those. So communication and the systems around monitoring the health are absolutely critical, and that's something that we established and built out over this time.
Yeah, that's a I was thinking harsh environments, and I was thinking of the cold and Alberta's environment. But you're right. I suppose many of these operations are in places that are not easy to get to, and you want that reliability of that the system is working and it's collecting data, and you've got reliable information to work on. I want to shift into a little bit. We've talked now about how Kuva's its origin story. Great evolution of the technology and technology development. And thanks for acknowledging ERA's role in that. And that's really, what we try and do is how, support projects and try and accelerate that technology development. But we know that the technology isn't just enough. You now got to deploy that technology. You've got to have that business case. There's the commercial aspect. Maybe for our listeners, can you comment on, you work with a partner like ERA to provide some of that support. How did that kind of support from ERA build your credibility with commercial partners?
I think it was critical. In the middle of the second ERA project, we were working with Synovus and Whitecap, and we were also putting quotes out to some partners, to some other potential customers. And when they learned that we were working with Synovus and Whitecap, these reputable companies here, and learned that we were able to demonstrate the value of the technology, that really convinced them to take that step to purchase and to go with us to try out our technology. And I think without ERA and without the collaboration we had with these partners, we wouldn't have been able to establish a relationship with these customers. And that was our first commercial deployment with somebody south of the border, because of the great partnerships that we built in ERA.
Yeah, it's great to start to hear this commercial applicability, and there's beginning to see the commercial success of some of these technologies. And obviously glad that we could play a role in that. What kind of traction did you start to see in other markets as a result of maybe that first order? Now you start to get your name out there, and there starts to be a little bit more recognition of Kuva Systems. Where did you start to see other interest?
Well, I think just geographically speaking, we saw a lot of interest coming from Texas and the Permian. I think there's a lot of eyes on that area. It's a heavy oil producer, and there certainly are a lot of emissions that do come from that region, and that is now our biggest customer base in West Texas and New Mexico. And I think, really that's all grown organically after the first initial deployments that we had commercially.
So, Thomas, it's great to hear about how, the success story. Kuva's it's one of those kinds of stories that we often like to talk about when we're out and about at conferences and meeting people. But obviously, not everything is easy, and there are always challenges and learnings. So want to shift into a little bit of that and get your insights in some of the tough lessons maybe that you've experienced over that time. So maybe to start with, what have been some of the biggest operational or technical challenges in getting the product to where it is today?
The way that our system works is it uses sunlight to detect methane emissions. So as sunlight passes through methane emissions and it reflects off the ground, we detect that absence of light as it passes through the methane emissions. And, some of the struggles we've had have been around, really the algorithms behind pulling that gas out, especially in low light conditions. So in the winter months here and when it's cloudy, there's definitely been times, and the way that the algorithms work, there's been a lot of evolution. So low light conditions are particularly challenging, or at least they had been more so. So optimizing those algorithms to really pull the gas out of the data itself was, and it still is an ongoing area of development, but we've made tremendous strides in being able to show gas in all types of environmental conditions now. And then, operationally, the market adoption, I think, educating the industry that, on the problem that they're trying to solve and how that they can solve it. Really, their problems are all about, fixing the cause of the emission. So not just detecting it, not just saying, okay, you've got some gas coming from that piece of equipment, but saying you've got gas coming from there. It's at this time, it's from this specific source location, and being able to compare that with your process data to come up with a root cause to say, well, it's because a separator dump valve was stuck, or the pressure in the tanks was too high, or something along those lines. That, convincing people that it's not just about the detection, but educating them that they need to have the context around the data that is really the driver to make them solve their problem. The two other primary market drivers are about regulatory compliance and emissions accounting. So proving that you are producing your energy in a responsible way with minimal emissions. And so the people who look at technology are often scientists and people who look at, spec sheets to say, okay, what's the best technology here for my role for solving this? And they're looking to see, well, what's the most sensitive detector? But really it's more about, well, what is the data telling me, as opposed to how sensitive is the detection. It's about the outcome. It's about being able to roll things up into actionable insights. So, for instance, convincing companies that we don't detect emissions at night. That's been a real kind of hurdle to overcome. So, because we use sunlight for our detection signal, convincing them that if we just detect during the day, that will help solve their problem more than just seeing, oh, emissions have happened at this time. So showing them where things happen and when, regardless of day or night, like it will get to solving their problem of having emissions, and really give them the insights that they need into resolving and mitigating those emissions.
Really enjoyed hearing that, Thomas, because, really getting to the fact that it's not just about maybe generating some data or generating some information. It's about what can you do with that to affect an outcome. And you actually got a little bit ahead of me. I was, going to, but maybe this is still a worthwhile question is, given that context you've just given, which is you have a tech that can do this detection and monitoring, what did you learn in your experience with customers about what is it they actually need when it comes to continuous emissions monitoring? It sounds like a part of that is understanding their need, which is to maybe, obviously mitigate emissions. But it sounds like you've also helped educate them on what this technology can do beyond just, that it can provide you data. It's what does continuous emissions monitoring actually enable you to do?
Well, I think context is the key word here. So providing data in the context of solving their problems. So showing them when something happens, showing them why and where, giving them that context and the certainty to show them an image that says that is the piece of equipment, that is the component that is emitting right now, and doing it in such a way that it's seamless. It's not difficult for them to have one click and see, okay, that is the problem. It happened here and it happened there, and you're able to really understand the where, the why, the what, and giving them that in as seamless a solution as possible, I think is what they really need. At least on the root cause side of things, that is absolutely critical. And then providing it in such a way that they're able to integrate it with their own current systems, their SCADA data, to be able to overlay these emissions with their SCADA data to show, okay, well, this correlates to that process event. I think that's all key to being able to deliver the solution that they need.
So where's Kuva Systems today in terms of its customer base and its geographic reach?
Yeah, so we've got cameras in the 4 western provinces. We're in, I think, 8 states in the U.S. We are in Australia and Brazil. To grow a customer base, you got to start with a pilot, and then you've got to prove to them that what you're providing them really works. And then, it's a bit of a long drawn out process, but it's certainly, you've got to provide them with the trust that they're looking for, and the fact that they're, what you give them is valuable, and you're not giving them anything, any false readings, false alarms. You need to, what is given to them is actionable information that they can rely on to solve their problems.
Yeah, you used the word trust there, and it's kind of where my mind went as you were offering that response. Is that's what they need? Is they, is data and information that they can trust, and obviously, as you say, take action to achieve an outcome. So when you think about looking ahead, what do you think the next sort of 12 to 24 months look like for Kuva Systems?
Yeah, I think, we'll continue to grow the bases we have, continue to expand into others neighboring regions, and I think we've got more hardware development that we've got on the back burner. I think we're about to, release a newer platform to give people better, more rich data experiences and context with the emissions events that we provide, so we can give it all kind of on a time series, equipment specific, to say, show me, be able to tell them all of the emissions that have come from one piece of equipment over time and roll it all up into some summarizable aggregates that they can, use in other means of reporting, such as regulatory or, environmental emissions accounting.
Well, it sounds very exciting. I'm also interested to get your thoughts and perspective on how do you see this methane detection space evolving, over time, and where do you think Kuva fits in within that picture?
The methane detection space, it's comprised of all sorts of different layers. You've got the satellites that have, high spatial frequency, and then you've got the aerial, and then you've got the fixed monitoring, and then you've got the mobile solutions. And I think they're all complementary. They're not really competitors. They're complementary solutions in different tiers that they all provide value to someone somewhere. So I think it's going to continue to evolve in terms of detection sensitivity. It's going to continue to evolve in terms of the scale of deployments, and I think it's really going to revolve around what people are the solving the problems that people need to be solved, and that's about reducing their emissions by root cause analysis. It's about the emissions accounting to prove that what you produce is sustainable and as low impact as possible. And then regulatory compliance. That's something that everybody needs to, be cognizant of and achieve those compliance measures. So that said, I think, our technology really, the sweet spot is, it's not the simple sites and it's not the refineries. It's the middle ground where there's, thousands of these sites. It's upstream, moderately complex sites where you've got, 4 to 16 tanks. You've got a number of other pieces of equipment, compressor stations, midstream, gas plants. And, I think the combination of our ability to survey an entire, a large area, and the accuracy that we can provide the leak source attribution, along with the ability to quantify, that's really a pretty strong portfolio to present with a customer, to say that, you can set up 1 or 2 cameras at your site and be able to accomplish kind of all of these 3 things: the root cause analysis, the regulatory compliance, and the emissions accounting. So that's the direction that it's going. And I think, there's going to be, each of those tiers is going to have a couple of winners. And I think we're pretty well suited for the fixed monitoring camera-based solutions. So
Thanks, Thomas. Great insights there, and I think a lot for our innovators, other innovators and listeners to take from that. One question we didn't cover, and I'm just curious, is because I had heard a little story of the name of the organization. How did you come about the name?
Well, yeah, sorry. I should have started the conversation with the initial name, the original name we had, which was a mouthful. It was Multi-Sensor Scientific. And try having that at the end of your email. We all sat together in a room, and there were several iterations that we had gone through and workshops One of our colleagues, Monica Spola, she's got a Finnish background. She threw Kuva out there, which in Finnish means image, short and sweet. And at the end of the day, that one won the votes, and it stuck. And I think it's been pretty memorable. And people talk about having their Kuva on top of a camera, on top of a tower, looking at their sites. And having my Kuva is pretty compelling, and it's maybe not quite Kleenex, but it's getting us there. So.
That's great. Thanks for sharing that really neat story about its origins. Thomas, thanks for taking the time and sharing your insights. Incredible journey and experience of how Kuva has evolved. I always like to make sure that give you an opportunity to cover anything that maybe we missed. Is there anything that you'd like to share about, maybe that I didn't ask about? What else do you think might be important to mention about Kuva?
Yeah, I think the fact that our path as a company, starting as a small U.S. startup and being able to establish roots in Canada and to grow the Canadian entity has really been thanks in large part due to the ERA funding. I think, the technology development and the has been incredible. And again, thanks to a lot of the funding that we've received, not just from ERA, but other Canadian grant agencies. And it's been a unique growth experience that I don't think, obviously, we wouldn't have a large Canadian contingent without that. And I think it's been amazing to have been involved with all these different commercial partners who've given us the feedback and the insights and the access to the information that we've needed. And it's really, benefited not just Calgary and Alberta and emissions reductions. Like there's been a number of wins because of this. So for all of that, I think we are very thankful to the ERA for, really injecting that initial and second boost to our development and growth as a company on both sides of the border.
And thank you, Thomas. It's a great story in terms of a great origin story, amazing growth, and a good example of technology development and advancement, and really trying to find that commercial need, which is where you've really got to marry that technology with that commercial need. So really appreciate you taking the time to share the story. It's been a pleasure working with you, and we wish Kuva Systems lots of success going forward.
Thank you, Craig. It's been a pleasure.